Alright, in this video I'm going to show you how to complete today's worksheet, the graphing, identifying variables and stuff. So we need to first identify, we're going to look at a bar graph. So we have the month and the number of deer. First, whenever you're trying to figure out what is the independent and the dependent variable, I is independent, right? So you can find the independent variable easily by asking yourself, which one of these did I have control over or could I manipulate? And you can manipulate the month. So the first step is we're going to identify our axes. So this is the thing that I can manipulate. So this is going to be our independent. It's going to go down here. Therefore, the number of deer is the dependent variable. From here, we need to set up our scale. We can't just start going 12, 15, 20, 26 all the way up, because the boxes, they have to be the same value. So whatever this box is valued at must be this. We can easily set that up by coming up with a proportionality. We need to figure out how many deer is going to be the value of one of these boxes. So if you count how many boxes you have 20 boxes total. So you're going to see how many deer do you have to fit in there. So you look at the maximum number. We'll just round that to 40. So if I have 40 total deer that I have to plot, but I only have 20 boxes that I can plot them across, it'll come down to a 2 deer per 1 box value. So you could put 2, 4, 6, 8, but that would get really congested. So I would recommend you have to tick mark 4, 6, 8, and I would only write the tens unit. And there's my number of deer, and this box has a value of 2, that box has a value of 2. All of them are equally spaced at 2 deer for 1 box. And now we have our month. We want to make it, spend it out, stretch it out as far as possible, because I know I only have 6 months, and this is a bar graph. So I'm going to denote these 2 is to September. I'm going to skip 1, October, November, December, January, and February. The reason why we skipped a little space, it'll make it a little bit neater, and the reason why I doubled up my columns is because you want to maximize the space. You want to use as much space as possible. So now we're going to graph. September there were 38. October 32. And that's your graph. So if you were going to describe this to someone who couldn't see your graph, you would just tell them, as we went through our winter months, or our cold months, we can summarize this as our colder months. As we went through our colder months, the deer population decreased over time. So what was the independent variable? That was our month, because we chose to look at these months, so I controlled it. We could have looked every other month, we could have looked at the winter months or the summer months. We chose these months. What depended on our month? Our number of deer. We want to title this. I would challenge you to title it not using these. So I might say deer population over winter. And then you would calculate the average. The average, you would add up all of these, would give you a number, let's call theta, and you're going to divide by however many that went into it, 6. I think that was 34, if I recall. For the next steps, I'm just going to help you with the graph. We're going to identify this as a line graph. Remember, the first step is to identify your axes. So if you have this data table, I have days and number of bacteria. Which of these could I control? That's the days. And the number of bacteria. So let's set up our scale, because now we have 200 bacteria. So if I have 200 bacteria, and I have 20 boxes to stretch them out over, we can simplify. So each one box has a value of 10 bacteria. So again, 10, 20, 30, 40, 50. Axis up. Remember, days is a line graph, so unlike up here where we identified the column, we're going to identify a specific line. We'll start at 1. Make sure again that they're evenly spaced, because your data will not look right. And what we're doing today is we are making a visual representation of a data set. If I can pause, some mistakes that came up in class when we went over this, some worksheet students wanted to reorganize this to start January, February, then September, October, etc. But you can see how that would look wrong if we took this and pasted it over here. The data wouldn't look accurate. We want it to show that it decreased over time. So you always write your axes as the data set describes. Alright, so now I'm going to, this is a line graph, so you're just going to plot your points. So if you were going to describe this graph to someone who cannot see it, you would simply tell them as time goes on, our bacteria increases exponentially. So what was the independent variable? That was days. Bacteria depended. It was a function of days. And a title could possibly be bacteria growth over a week's period. Now we're going to make a bar graph. We're going to see study hours and grade. So which of these do I independent, do I have control over? And that is the hours. What depended on the hours of studying time, that was your grade. Set up our ratio to see how much value each one of these boxes get. If I have 100% in 20 boxes, set it up. So 5% will go in one box. Difficult to see. Did the best I could. And then hours is going to go down here. This is a bar graph, so you're going to want to identify the columns. We're going to start 0 over here. And then graph. So if you were going to explain this graph to someone who cannot see it, you might tell them the more time you invest in studying, the longer you study, the higher your grade is. We can see that the more that they study, the higher the grade percentage goes. This is our last one. This is a line graph. We have temperature and enzyme activity. Which of the two do you have control over? What should I do? And I can control the temperature. We're going to put temp down here. Make sure you put it in degrees Celsius. Units are very important. And enzyme activity over there. I'm shorthanding it. Please do not shorthand on yours. We need to set up a ratio. There are 20 boxes. I need to go 20 enzyme units. Therefore, one box would be 1 unit. And then we have temperature over here. But look, you can see that it skipped one. Just because it skipped one does not mean that you can skip it. You must make every single box, even on the x-axis, equal. So we're going to start 0 here. We're going to put 10 here, 20, and keep going. And make sure that you identify which line is getting that. So let's graph it or plot your points. So if you were going to describe this graph to someone who cannot see it, you would tell them as temperature increases, enzyme activity also increases until a critical temperature. At 40 degrees, enzymes start to degrade or denature. So as temperature rises, enzyme activity rises until 40 degrees Celsius, and then they decline. I hope this helps you. Have a good day.